Very good evening, guys, to another session. How are you all doing? कैसे हैं आप लोग? All good? Okay. Yeah, I'm good as well. Uh, Hi, everyone on the YouTube. How are you guys doing? Many of you were waiting. So, all right. We were doing something last time. We were talking about, so basically what we are doing is we are not doing anything in continuity for the time being. Because as I said to you from the very start, right now these classes are just demo classes. The actual batch would begin from 10th May. Before that, we are having an overview of some of the topics. So like last time we talked about Newton's laws of motion, it was not limited to only that. Newton's laws of motion is a very vast chapter. We'll almost do that chapter for a month. For that long it'll go. Okay. So we just kind of took few parts of that in one of the lecture. We saw what it has to offer. Similarly, today also we'll be doing a chapter called friction. It'll only give us an idea what we are supposed to see in that chapter. The real chapter of friction will go on for many classes. It would go on for 7 to 10 classes almost. So it's a vast chapter because everything has to be done in so much detail for JEE. Also, right now I'm keeping level of questions also very easy because these are the topics you're studying for the very first time. When we'll be doing an actual class, we'll be doing many more good level questions. Okay. Yeah. So let's continue in that series. And today also do a topic which is related to friction. So let's learn about friction today. So I'll quickly share my screen with you all and we'll start. All right. So today we are talking about a topic called friction. Let's understand a bit about friction first of all, and then we can do some problems based on it. So I think all of you must have experienced this, that whenever you try to move any object around you, especially the heavy objects. So let's say the couch you want to move from its place. So if you apply a little force, initially the couch doesn't move. Then you increase your force and suddenly the couch starts to move, right? So basically you have to cross a particular value of force in order to make it move. Before that, it won't be moving. That is something we all have seen, experienced. So yes, we require a particular value of force that needs to be exceeded. But my question is, initially also when it is not moving, you are applying some amount of force which cannot be neglected. It is a non-zero force that you apply and still the couch doesn't move. Okay, maybe let's say the force required to move couch is 100 Newton. So when you're applying 90 Newton, it's not moving, but still you're applying 90 Newtons, isn't it? 90 Newton is not a small force, but still it doesn't move. What is the reason? Because according to Newton, any kind of force applied produces acceleration, F equals ma. So why the couch doesn't move initially? Any reason?
Due to static friction.
Yes, or we can say that although we are applying 90 Newtons, which is a tremendous amount of force, but there must be equal amount of force acting on it to oppose its motion. All right. And that opposing force is created by the ground because it's kept on ground. It won't happen in the space. In space, even if you apply 1 Newton, it will start moving. You won't need a huge force to move it, right? So it happens because it is kept on the ground. Ground applies an opposing force. So this is what happens. Any object which is kept, if you apply the force F, an opposing force appears from the ground, which is opposite to your force. and it completely balance out your force. Okay. Now we shall understand the nature of this force. What do you think? Is the value of friction always fixed or it keeps on changing? What do you guys think?
Changing.
Yeah, it keeps on changing. Yes, you're right. Why? Because if let's say I apply only 10 Newton of force, then friction will apply only 10 to cancel it out. We increase it to 20, friction will increase itself to 20. We increase to 50, it also increases to 50. So see, it always follows you. Friction is always a reaction force. It's never an action force. That is something we must remember. You may even write that statement that friction is always a reaction force. It cannot act by itself first. It is always in response to some other force. Okay. So it tries to balance you out. It's a kind of reaction which tries to balance you out. So 50-50. But we saw that you can keep on applying and the object is not moving. Let's say the moment your force reaches 60, now you're getting a feeling that, okay, the couch is about to move, but it has still not moved because even now the friction is applying 60. It's balancing you out, but you have already got the feeling it's about to. And the moment you even go 61 Newton, suddenly it starts to move. Now, can you guess why it started to move just after 60? Why it could not continue beyond that? Because friction stopped. That was the limit of friction. There is a limit to the friction, isn't it? The maximum value friction could have applied to oppose you was 60. And after you exceed the 60, you're out of the reach of friction. Now, any force you will apply beyond this, friction won't be able to balance. So will the friction stop acting? No, it will still keep on acting there. So let's say when you are applying 61 Newton, friction is even now 60. It tries its best all the time till its last breath. It tries its best, which is 60. So now when you're applying 61, how much is the actual force felt by the block? 1 Newton. Yes, you're right. Yes, Cavalier. Kishore, right. Now it will be just 1 Newton because 61 to the right, and out of that 60 will be balanced by friction, and the net effect block would feel will just be 1 Newton. Okay. Yes, Neil, right. So that's about friction. Friction just tries to oppose you as much as possible. All right. That's what it tries to do. Now, it implies friction has a limiting value because I told you that's limit, right? It is called as the limiting value of the friction. Or in a simple word, we can also say it's the maximum value of the friction. So limiting value or the maximum value. That's how we define it. Now comes the question, how do we find this? Doesn't friction depend on the weight of the object also? Not really weight, but something else, which we will going to discuss. So now that we know there is a maximum value to the friction, even this maximum value is not fixed. This maximum value of friction will be different for different types of object. If I keep a heavier object, then there'll be a different value of limiting friction. Just like what Jay and Jayani last year, that shouldn't friction depend upon weight? So I'm saying not exactly weight, but there is some other thing which we need to look after. So let's go into that. Now we are learning what affects the value of friction, especially the maximum value of the friction. Again, we should try to learn it from our experience. Every formula that you see in physics has come out of some thinking, which you are also able to do. You can actually do that. So suppose here is a heavy block and here is a lighter block, A and B. And you apply some force. Which one will be easier to move, A or B, heavier or lighter? Lighter will be easier to move. It can move quickly, right? Reason being, it has lesser weight. So that means it gives us an idea that it's easy to move lighter objects. So friction must depend upon weight. That's what it gives us the implication. But I'm saying no, not actually weight. Because now I will put in front of you an example where both blocks will going to have same weight. Here. Now I take two identical block B that we saw there. Both are block B only, same weight. All right, both have mass M. But in one case, block is kept normally just like this. In the other case, your friend is applying a force from the top. Your friend is pushing the block from the top. Okay, a pushing force is applied towards the ground. So what do you think? Both have same weight. Will you require equal effort to move them or different?
Different efforts.
Different effort, right? That means it has not directly to do with weight. It has something else to do with. And what is that something else? It has to do with how much, no, even mass is same, Kishore, here. Even mass of both the objects are same. It has to do with how much force the block pushes the ground. How much force the block applies on the ground. That is what it depends upon, right? In the second case, the force applied by block on the ground is just its weight, mg. While in second case, the force applied by the block on the ground is weight plus that force applied by your friend. So it's more. And that's why the friction in first case will be more. All right. So I hope this is something which all of you are clear with. Yeah. Force on ground. Now, how do we find how much force has been applied onto the ground? Well, we can use the Newton's third law. What Newton's third law tells? It tells that every action has equal and opposite reaction. If block is applying some force on ground, then ground must be responding back with the same force. And that force is what is called as the normal reaction, N. So what is the force applied by the ground? Normal. Why the force is called as normal? Because it acts 90 degrees to the surface. All right. Hence, it's named as normal. And also there is one more word to it. It's normal reaction. Normal reaction force. Normal for the reason that it's 90 degree and reaction for the reason that it's a reaction to the force applied by the block. If block applied mg plus f, then in that case, what will be normal equal to? It will also be equal to mg plus f. In case where block applied just its weight, then ground also applied just mg onto the block. Or if we clear? This is the reason how we are able to sit on a chair. We push the chair with our weight and chair responds with a normal reaction that is equal to our weight and we stay there. Right, so I hope everyone clear with this. What if normal is not present? Normal has to be present as long as you're pushing the ground. Shivangini, normal can only not be present when you are in air, you're floating. When you're floating, you're not pushing the ground, right? So in space, there won't be any normal reaction. If you're sitting on the ground, you're standing on the ground, you're already pushing it. So normal has to be there. Water doesn't apply normal reaction, or if it applies very less, not equal. And that's why if we try to stand on water, we fall down because it's normal is not enough. So what you have to do in order to float in water, what's swimming all about? Swimming is all about pushing the water down, right? So you apply a huge force on water with your hands and feet, and that causes you to move up. So you push the water down, water pushes you up. So that's called normal reaction. So guess what, guys? Friction should be said to depend on normal reaction, not the weight, isn't it? So that's the first conclusion we draw, that the maximum value of friction we are talking about, F max, must depend upon normal reaction. First conclusion. Let's try out the next conclusion. Suppose the same two blocks of mass m. First one I'm keeping on an ice slab. So this is ice. While the second one I'm keeping on the sand. Now both blocks are same. Both have mass m, equal weight. So there will be equal normal reaction also, right? This one would also be applying its weight mg. This one will also be applying its weight mg. In both cases, normal reactions from the ice or from the sand is same, mg only. So ideally, according to us, we should require equal effort to move them. But do you think that is the case? No. Which one will be difficult to move? Yeah, the one on the sand will be difficult and one on the ice will be easy to move. On ice, it can slide very smoothly, isn't it? While on sand, it cannot. So what happened? That means normal is not the only factor. Normal is one of the factor. The other factor is about looking at the type of surface where you're moving, right? So friction also depends upon what kind of surface it is, whether it is a smooth surface, whether it is a rough surface. All these factors actually depend. So on what factor do they depend? There is a factor called coefficient of friction. Coefficient of friction is something that tells you about how rough or smooth a surface is. It's written by a Greek letter mu. So what you see here is not u, it's mu. Okay. Greek letter mu. And this mu always lies between 0 to 1. This coefficient of friction is used to tell you how rough or smooth a surface is. So what is the use of coefficient of friction? To tell you how smooth the surface is. If coefficient of friction is high, that is, it is approaching towards 1, it means very rough surface. And if it is very low, it's approaching 0, means very smooth surface. All right. So here, if I write mu1 and mu2, the two coefficient of frictions, which one will be greater? For sand, it will be greater, or ice, it will be greater. Yes, Ellen, you're right. What about others? Yes, Shivangini, Shambhavi. Cavalier. What about rest of you? Yes, so sand is the correct answer. Sand will going to have more coefficient of friction. Why? Because it was difficult to move it through sand. It was a rough surface, while ice was easy to move. That means ice was a smooth surface. And what did I tell you about now here? That for a smooth surface, coefficient of friction is low. And for a rough surface, it's high. Okay, now if we combine both now, we know there are two factors friction depends upon. First was the normal reaction. Second is mu. And when we combine, that's when we get the formula for maximum value of friction as mu into n. So see guys, I could have started this concept by giving you the formula first, right? I could have said that, okay, this is the maximum friction and this is the formula. But I didn't do that because I wanted you to arrive at it. If we just see things happening around us, we can arrive at most of the concept of physics, because that's how the original scientists actually arrived. They also saw things around and then they had drawn this conclusion. And that's what approach every student must keep if they want to become a good engineer or any other kind of thing. All of you have taken PCM, or even if you're taking PCMB, innovative approach should be there. All right, so F max is mu into n. Okay, so let me check how many of you have understood what I have taught so far. Suppose there is a block. Its mass is 4 kilograms. And between the surface and block, the mu value, coefficient of friction, is 0.2. Suppose I apply a force of 6 newtons on the block. What will be the acceleration of it? What will be the acceleration of the block? Okay, Ellen is giving one answer. What about others? Shivang got something else. Yafi got some answer. Okay, Akhil got something. but only so far Taha got correct. Rest all were wrong. So Taha, your answer is right. And he answered it in the everyone. So Taha, next time try private chat so that other can also think what was the problem. Guys, here the answer is it won't even move. All those of you who answered 1.5, you simply did force is 6, mass is 4, just divide. Acceleration is force by mass. You completely forgot that there is friction also. You need to consider friction as well, isn't it? So 1.5 can't be the answer. So first you would have to check how much friction this surface can apply. And how would you check it? By this formula, which we just now derived, mu into n. So let's check how much maximum value of friction the surface can apply. So mu is 0.2. And what will be the normal reaction here? Normal reaction will be same as the weight of the block. Block is applying its weight, which is 40 newtons. So normal will be equal to it, right? Normal is keeping it stationary. Just like you're pushing the chair, chair is responding with the same force. So normal is also 40. And that gives us that maximum force friction can apply is 8 newtons, right? So as long as you apply force lesser than 8, friction will kill your force immediately. It is under the limits of friction. And look at your force. Your force was within the limit of friction, 6. So friction immediately applies 6 Newton to balance you out. I can't understand how 40 came. Ellen, it's the weight, mg. Mass is 4, gravity is 10. So 4 into 10, 40. Right. Weight of the block is 40 here. So everybody clear? Yes, G will always be taken as 10. Until unless not mentioned, it will always be 10 for calculations. Because this makes calculations very easy. Would you please re-explain it? Yes, Chandraba. So we saw that friction is given by mu into n. And now mu is 0.2. And we wanted the value of n. N means what force ground will apply. So if let's say you are standing on ground, your floor, how much force the floor is applying on you? So how much force the floor is applying? Yes, Chandraba. If you stand on water, you fall. If you stand on a hard floor like this, you don't fall. Why? Because this floor can apply a force on you, which water cannot. And yes, that force should be equal to your weight. When you stand on the floor, you're pushing the floor with your feet with a force equal to your weight. And so the floor has to apply an equal force on you, normal reaction, which would come out equal to your weight. This normal will be equal to your weight. That's what happened with this block. The normal is equal to its weight. Its weight was 40. All right, so that's it. I hope everybody understood how friction is done. So let's try a few more questions. So suppose you must have tried balancing object against a wall. Have you ever tried that? Even with the vertical walls, we can balance objects. Like there's a box which you want to balance against the wall. What you would have to do, or maybe your book you want to balance against the wall without using any glue. So what would be required to be done?
Friction.
Yes, you press it against the wall, isn't it? By pressing it against the wall, by applying a force, we can keep the box stationary. Can anybody understand this? By pressing it against the wall, we can keep it stationary. Now let's say that the mass of the block is 2 kilogram. It's a 2 kilogram heavy object. And the coefficient of friction between wall and the block is 0.5. Then can you tell me minimum how much force you need to keep it stationary? How much force you should apply to keep it stationary? Because you know, if your force is little, then it'll going to fall. You have to press it really hard before it falls. And heavier the object, more is the force required. So that's what we are asking here. What is the force required to balance it? Okay, many of you have answered. Let me see the answer myself. So there is no N in this case. Why not, Shivang? There is. You're pressing the block against the wall. Wall will apply a normal. So there is a normal. So far, none of you answered correctly. All the answers are wrong. So please try once again. Uh, yes, Ellen, that is definitely true. But what is the minimum that you need? How much is the minimum force you require? Like that, Ellen, I can even say above 0. So obviously force is non-zero, so even that is correct, but we need minimum value. No, so far none of the answer is right. Nope. No. None of you is correct so far. Yes, F is the force you are applying. Anyone on YouTube who can answer? Okay, finally I got a correct answer. That is from Ihsan. Ihsan answered correctly. And even Taha is answering correctly now. The rest all are still wrong. On YouTube also, nobody has answered so far. All of you are wrong. Nope. Only 2 people correct so far, Ihsan and Taha. Okay, I think it's time I should solve. No, Kishore, not correct. I think I should solve. So see guys, first of all, think about what will be the normal reaction. You press the wall with a force F. So what will be the normal reaction by the wall? Same force F only. Your action is of force F. So wall responds with a reaction of force F only, isn't it? So that's the normal reaction, your force. And if book is not falling, why it's not falling? It is having its own weight acting on it, m into g. Mass is 2, gravity is 10, so that's 20 newtons of its weight is acting on it. But still it's not falling. Somebody is pulling it down, gravity is pulling it down, but still not falling. Why? Because friction acts upward to balance it. It's like tug of war between gravity and friction. And if it remains stationary, that means friction is balancing out the earth. Earth applies a force of 20 Newton. Friction also applies the same, right? And it balances out. Now, how friction is given by? It's given by mu into n. What is mu? 0.5. What is n? The force we have applied. That should be 20. So F is 40 newtons. This much force we need to keep it stationary. Okay, done. Everybody understood what to do? All right. Let's move to the next problem. Do you guys remember the example I gave you last time where I had kept an object over a board, like this black colored board, which you see? This one, I guess all of you can see this blackboard, and I keep an object over it. Due to virtual background, it's going on and off. I think now it's visible. All right. Maybe I'll stop sharing my screen so that you're able to see me properly. You get a maximized view. Or if you can pin my camera, my video, you'll get a maximized view. So all of you can see a box is kept. Basically, it's an AC remote I have kept here on this flat surface. Now what I'll do is I'll start tilting this blackboard. Can you all see I've tilted it? And still the remote is not moving. It remains there. And last class we learned gravity's component is acting. It's trying to pull it down, but still remaining there. Why? Who is stopping it from sliding down? Friction. Friction is not allowing it to fall down. But watch, as I keep on increasing, how amazing it is. Even now it has not moved. See how tilted it is. Almost I'm at 45-degree angle from horizontal. Almost 45. Now it went. The moment I went a little above 45, it was gone. Yes. So basically, as you realized, friction has a limit. So as long as the angle was under the limits of friction, it maintained, it remained there. The moment the gravity's component went beyond the limit of friction, remote falls. Let me show that now with some calculations. So what we have is any object on the inclined plane of this sort, tilted. Let's say making theta angle with the horizontal. Here is our block. Block of mass m. What all forces will be acting? So last time we saw that if gravity which acts vertically down, we can actually take two component, one down the incline and one perpendicular to incline, right? That's how we can take two components. And we even saw what these components would be. We said that this is a right angle triangle. This is theta, that's 90 minus theta. So this has to be theta. And we always saw that angle towards the component, component towards the angle was the cos. Now, guys, I know for some of you, this would be right now a little difficult. What is going on? What is this component where cos thetas and sin thetas came into picture? So don't worry. This is all done in vectors. And when on 10th May, our classes would be starting, the first chapter we'll be doing will be will be calculus and vectors only. Okay. Calculus will be like the basic math that is involved in the physics, and vectors will be a chapter in itself. So in vectors, I'll be teaching you in very much detail how we get cos theta and sin thetas. Right now, you can take it as fact till 10th May. After 10th May, you'll be knowing the reason how this happens. Okay. So one component will be mg sin theta. The other component will be the mg sin theta. So the force that pulls it down the incline is mg sin theta, as all of you can see. Mg sin theta is pulling it down the incline. But initially it doesn't move because friction tries to stop. Friction acts up the incline. Friction fights. Basically, friction is a force that likes tug of war. It always go under tug of war with its opponents. And it tries its best up to a certain point. As long as the opponent is weaker within its limit, it is able to hold. The moment opponent is stronger than its limit, it loses the tug of war. And one more thing, friction never wins the tug of war, isn't it? You would never see object starts to move up the incline due to friction. It never happens. The minimum or the maximum friction does is to keep the rope stationary in the tug of war, not letting the rope move. That's all it does. So is the statement friction is more than gravity correct when angle is less than 45? Yes, Shivangani, right? Now, guys, think about it. Why initially the remote was not falling? Because you realize the component of gravity that's pulling it down the incline depends upon the angle, right? And as long as your angle is small, sine theta will also be small. Sine of 0 degrees is even 0. So in case of horizontal, block won't even move. Only when you start tilting a little, this force appears. So as you will be increasing theta, this force will be growing. The opponent's strength is going up. The opponent which is fighting against the friction is going up. And it happens to win after it has exceeded the limit of friction. When even the maximum friction is acting, and mg sin theta is able to overcome block would move. So when the block would move, we'll write here, block would start to move when mg sine theta will become greater than maximum value of friction. When the downward pulling force will even overcome the friction. The remote slides down. So far, everybody clear with this? Okay. Now let's see what F max would be. If suppose we are told that surface has coefficient of friction mu, then we can even write what this F max would be. Mg sine theta is as it is. It must be greater than mu n, right? Now let's see what normal reaction is. Remember, what is normal reaction? Force applied by ground on the block. Now think about it. With what force the block is pushing the ground? Now ground is not horizontal anymore. Ground is this inclined one. So on this inclined plane, how much force this block is applying?
mg cos theta.
Mg cos theta. It is pushing the incline with this force. See, like this, isn't it? Are you guys understanding? We always see in a direction normal to surface, perpendicular to surface. So perpendicular to surface is this only. And so the ground responds with a normal reaction like this, which would also be equal to mg cos theta. I hope this part is clear to everyone. If you're standing on horizontal surface, you will push with your weight. But if you're standing on an inclined plane, you will push with lesser than your weight. And that's why, have you ever tried taking your weight on an inclined surface? Put a weighing machine on an inclined surface and go and stand there. Will you get your actual weight? Will you? No. What is the reason you don't get your actual weight on inclined surface? Because you're no longer pushing with your weight, isn't it? You're no longer pushing with your weight. You are pushing with a force lesser than your weight. You're pushing with mg cos theta now, not with mg. Everybody clear? That's why your weight comes out to be lesser. And remember, weighing machine never measures your weight. I'm telling you something which might seem very surprising to you. Weighing machines don't measure your weight. So what do they measure? They measure the normal reaction. With whatever force you will push on the weighing machine, same force it will give the reading of. So if you're standing on incline, you're pushing with a lesser force, it will show lesser reading. If you are having your younger sibling on your shoulder and you're standing on weighing machine, and now you're pushing it more than with your weight, even the weight of your younger sibling will be counted. With both forces, you're pushing the weighing machine. So it will give much bigger reading than before now. So weighing machine always measures normal reaction. It even happens on grass. What happens on grass, Shivangini? It shows wrong weight. Okay, I never heard about the grass wala part. Because as long as even you have kept some weighing machine on grass and it is flat, then there won't be any issue. If it's quite muddy, then obviously there'll be a problem. Okay, so n equals mg cos theta. That's the normal. So let's substitute. Remember, we are solving this equation. Mg sine theta must be greater than, must be greater than mu times n, and that normal reaction is mg cos. And so we find out that at what angle the block started to slide down. And so amazing thing you're observing here. Just look what is happening. Weight is canceling out. Sine theta is greater than mu cos theta. And we find that the angle at which the block starts to slide down is this. Tan theta greater than mu. When tan of theta becomes greater than mu, block starts to slide down. And amazingly, it doesn't matter what kind of block it is, whether it is a lighter block, whether it is a heavier block, and you can even try that. It won't depend upon the mass of the block. All of them will start sliding down at the same angle. And guess what? We cannot measure mu, right? Mu cannot be measured. We cannot measure roughness of a surface. There is no machine to measure it. But at least we can measure the angle at which starts to slide down. Like remember the example I gave. In that case, at what angle it started to slide down? What angle the remote went down? It went down at 45, right? 45 degrees. So if you put here tan 45, our mu was lesser than tan 45, just slightly lesser. In our case, it was equal, right? Almost exactly at 45, it went down. So we should take equality. And tan 45 is 1. That means based on that experiment, I can measure the coefficient of friction. That the surface I took has a coefficient of friction of 1. And guess what? You all can do it. Pick up any kind of surface around you and immediately measure its coefficient of friction. So the mu, which looked quite unknown to you, is experimentally measurable and so easily that you can do it at your home. Correct? All right, now this is not smooth. One value of mu means very rough surface. If it was a smooth surface, it would have slid off even at a smaller angle. Immediately it would have gone down. So if you can write it down. Why is it equal to 45 degrees? Because the example we did, Samiksha, the experiment we did, where we found it to be 45. So I just took an example. You can write there for our experiment. Right now we did an experiment, right? With that board and remote for that particular case. Okay, so everybody clear? Right. So let's do a few more questions of friction. Suppose there's an inclined plane with inclination angle 37 degrees. Now you might be surprised that, sir, what kind of angle you have given? 37 degree. Isn't that a non-standard angle? You could have given easy angles like 30 degrees, 60 degrees. Why you did like this? Because have you noticed something about 30-degree and 60-degree angle? See, here we'll be using both sine and cos, right? If at 30 degrees sine is half, what is cos at 30 degree? Root 3 by 2. Irrational number, right? What about 60 degrees? Well, cos of 60 may be half, but sine of 60 would be root 3 by 2. So the problem is, and if we take 45, both will be 1 by root 2. So all these standard angles that we see, at least either sine or cos will be irrational always. Both of them cannot be rational. But believe me, not believe me, you can check it out later also as a fact that 37 degrees is a triangle or is an angle where both sine and cos will be rational numbers. It is such a good angle. And you know why it is such a good angle? What the triangle of 37 degrees look like? It is of the sides 3, 4, 5. That's the triangle of 37. So this is the best angle you can ever imagine. Just check what is sine 37 here. Perpendicular by hypotenuse, right? How much is that? 3 by 5. And just check what is cos 37. That is base by hypotenuse, 4 by 5. So see, both of them are rational. That's why 37 degrees is the best we can imagine. Okay, now what I do is I keep a block on this incline. Its mass is not given to us for some reason, maybe that you have to figure out. The mass is not given. And we are being told that the coefficient of friction here, mu, is 0.8. Oh, wait. No, it should not be 0.8. I'm sorry, it shouldn't be pointed. Otherwise, the block won't even move. Okay. For block to move, mu should be lesser than that. So lesser than that should be around 0.5. 0.5 will be the easiest to take. So, all right, so far it is clear. Mu is given as 0.5. Block is there. And the block will going to slide down. We are being told that the height of this inclined plane is, let me check, 6 meters. This inclined plane is 6 meter high. And if we have released it from there, from the top position, release means initial velocity 0. Then after how much time it will reach the bottom of the incline? How much time it would take to reach the bottom of the incline? Okay, so Ellen is giving something else. Taha is giving something else. Alan, then that won't be correct. Yeah, so everybody try what it is coming. Even Taha, yours is not correct. No, Taha, not right. No, Ellen, even that's not right. The answer would actually be an irrational number. Guess what? Time will come out irrational. No, Shivank. So should I discuss, guys, or you're about to get it? Not getting? Okay, let me discuss. No, Cavalier, although you were very close to the answer, but that's not true. So guys, first what you need to do in order to find the time, you need to get the acceleration, right? With what acceleration it's going down? No, Samiksha, not right. With what acceleration it goes down, that's what we need first. Let's look at what all forces are acting on the block. If I see what all acting on the block, we know there will be one mg sine theta. Do you guys remember? The component of gravity, mg sine theta, this one. Friction will be acting up here. And it will be doing an acceleration downwards. So what will be its acceleration? No, Taha, even that's not correct. No, Kishore. So with what acceleration will be going down? Mg sine theta is greater than friction, right? That's why it's moving downward. So the difference of these two forces will be the net force. Remember, I told you that if we are applying 61 newtons, where is that example? This one. I said we are applying 61 and friction is applying 60. How much the block would feel? The difference of the two. So that's what happens here. Mg sine theta minus F, that difference is what will give the block acceleration. F equals ma. All right. Now let's see what will going to happen. What will be the friction here? Friction will be mu into n. And what is n? Mg cos theta. That equals ma. And guess what? Mass cancels. And that is the reason the mass was not given, because it cancels out. Now you can see I can take g common. Inside I have sine theta minus mu cos theta. That equals a. We can put the values and see what we are getting. Gravity is 10. Sine 37 is 0.6. 3 by 5 means 0.6 minus mu is 0.5 and cos theta is 4 by 5, isn't it? 4 by 5. That's a. So what is inside the bracket? That will be 0.6 minus 0.4, which is 0.2. 0.2 into 10 is 2. So acceleration is actually 2 meters per second square. That's the acceleration. They substituted the values, nothing else. Now, after we've got the acceleration, we know initial speed is 0. We need this displacement s. How much the block would travel. So you can see I have perpendicular and I need hypotenuse. So sine 37 I must apply. Yes, Cavalier, you got correct. Sine 37 here, see. Sine 37 is 6 by s. Sine 37 is 3 by 5 and that's 6 by s. So s comes out to be 10 meters. The displacement of the block is 10. Its initial speed is 0. A is 2. We need the time. Second equation of motion. S equals ut, u is 0. So half A is 2 times t squared. And you realize time is root 10. Yes, Shivank. Root 10 seconds. So all of you clear with this? Okay. So guys, now that was just to give you an idea what you are about to expect in friction. I know many things might not be clear right now because honestly speaking, you need a lot of practice before even to reach this chapter. And after we start our batch, we will take almost 1 or 2 months to finally arrive at this concept. By then you would have practiced quite a lot. At that time, you will find these things relatively easier. Okay, because you would have done so much practice before. So don't worry if you're not understanding anything right now. After 10th May in the regular batch, things will be very different. All right. Yeah. So that's all we should keep today. Any new concept we'll be learning now in the regular batch itself. So now next we'll be meeting in the batch itself. Okay. On 10th May. 10th, Shivangini. For physics class will be around that only. So can you show sign 37? I just remember the triangle, Akhil. Triangle is 3, 4, 5. All right. Okay, guys. So goodbye, everyone. See you all next time. And the people on YouTube, if you want to join, then go for the enrollment in the batch. Okay, we'll see you there. Goodbye, everyone.